we'll start talking about this thing called normal distribution. So one type of probability distribution is normal distribution, and it's always going to be modeled by a bell-shaped curve, and we call that a normal curve. And it's symmetric about the mean. So it's important that we know the mean of a data set because normal distribution is going to be centered around that mean. So for this first example, normal distribution with a mean of x and standard deviation, we need to know mean and standard deviation sigma. That's always going to be important when we're talking about normal distribution. A couple things to keep in mind. Whenever we're talking about total area under a curve, it's under the related normal curve, it says it's 1. And that 1 is like a probability. Or we could say it's like 100%. Basically, 100% of the data will fall under the curve in normal distribution. That's true every single time. Okay, that's what normal distribution is all about. So when we're talking about decimals and probability, like if you get a probability of 0.997 that something's going to happen, that means 99.7%. Okay, that's what that's how the percentages and the probabilities relate with this thing, normal distribution. So whenever we have a data set of like 10 or 12 points, usually normal distribution is going to be more points. It's usually at least 30. And so normal distribution is typically like 100 data points or something like that. So that's why we start dealing with this curve instead to kind of figure out in general where do you think an actual data point would fall in relation to the distribution. That's kind of what we're talking about with normal distribution here. The first thing says about 68% of the area lies within one standard deviation of the mean. So the way we do normal distribution is we put the mean right in the middle. So there it is. And then if we add one standard deviation to the mean or subtract one standard deviation from the mean, that's where 68% of the data will fall. That's what that means. And I kind of talked about that yesterday where I said about 2/3 of the data. It's actually 68, so it's a little bit more than 2/3. But that's what I was referring to yesterday. So if I have 100 data points, theoretically, and it's normally distributed, 68 of them will fall within one standard deviation of the mean. That's what that means, okay? With simple numbers there, all right? And then 95% of the data will be within 2 standard deviations of the mean. Okay, so 95 out of 100 data points would fall within 2 standard deviations of the mean. And then the last one, 99.7% will fall within 3 standard deviations of the mean. So if I have 100 data points, then 99.7 of them theoretically would fall within 3 standard deviations of the mean. But if I expand that to 1,000 data points, then 997 of them would fall within 3 standard deviations of the mean, and that means 3 of them would be outside of the 3 standard deviations, which means it's really, really rare to have a data point that falls outside of 3 standard deviations of the mean. That's kind of where the outliers would be, is kind of beyond 3 standard deviations of the mean. Okay, that's kind of a good way to tell about an outlier. All right, this second data set over here on the right, this shows the standard deviations being added and subtracted 3 standard deviations up and 3 standard deviations down. But it breaks down the percentages more like, hey, just so you know, 0.15% would just be this small area right here. If you wanted to find the area between 2 standard deviations and 3 standard deviations on one side, that's 2.35%. If you wanted to find this area right here, that's 13.5%. And if you added all the percentages up, that would add up to 100%. All right, that's what these two normal distribution curves are for. And those are going to be helpful today on our lesson and on our assignment. All right. And now, before we get started today, I'll show you a real-life example of normal distribution. Back to our iPad now. Our first example today, we'll take a look at how this is going to work for us. I got a little dot there that's not going to go away. So this says, the blood cholesterol readings from a group of women are normally distributed with a mean of 172 milligrams per deciliter. So we're going to put 172 right there. That's the mean. That's the middle. All right. And what will happen sometimes is I'll give you an example where you don't have a curve drawn, and you might want to draw your own curve. To draw your own curve, all you need to do is draw a flat line and then draw a nice curve. That's it. So if I ask you to draw your own curve, it doesn't need to be perfect, but you want to draw something that's generally pretty good bell-shaped curve. And that's how you could draw your own normal curve if you don't have one provided for you. On the homework assignment, you might need to draw your own, or you might be asked to draw your own. So just be prepared for that so you know how to do it. Okay, so this first one says the mean is 172 and standard deviation is 14. So what you do is you'd say, okay, I want to go one spot above the mean. That's going to be 172 plus 14. And then I go 2 standard deviations above the mean. That's 172 plus 2 times 14. 3 standard deviations above the mean is 172 plus 3 times 14. And then go in the opposite direction, it'd be 172 minus 14. 172 minus 2 times 14. And 172 minus 3 times 14. That's how we identify our standard deviations. 172 plus 14 is 186. 186 plus 14 more is 200. 200 plus 14 more is 214. And whenever we're doing a normal curve, I think it's really useful to put all 3 standard deviations above and all 3 standard deviations below before we do any of our calculations or any of our problem itself. So 172 minus 14 is 158. 158 minus 14 is 144. 144 minus 14 is 130. All right. So that means that 3 standard deviations below our mean is 130. 3 standard deviations above our mean is 214. And again, those are all blood pressure levels for this problem. So part A asks us to label the normal curve using the information provided. And we've done that. Part B now says, about what percentage of the women have readings between 158 and 186? So it turns out 158 is right here. 186 is right there. So the percentage of women that would fall in that category would be, from our list above, 68%. That's 1 standard deviation. Okay? So 68% fall in that 1 standard deviation range. All right, that's how we'd figure that part out. All right, just using the information from above. So about 68%. All right, that's using the graph on the left. Now the second part, part C, says readings higher than 200 are considered undesirable. About what percent of readings are undesirable? So now, if I look at 200 here, that's 2 standard deviations above the mean. Anything above 200, that's going to be all of this stuff over here. This one's going to require the graph on the right up here. So it's going to be this 2.35% and this 0.15%. That's going to be all the things that are above 200. So you would say, 2.35 plus 0.15, add them together, and you get 2.50%. So essentially, 2.5% of the people in the survey are having readings that are considered undesirable. That's what that means. I'm going to put a decimal there, 2.5. All right, that's what part C is asking us to do. Okay, that's how normal distribution works, and that's how we'd use those 2 charts above to help us. If I needed to label my own graph, I would go ahead and say mean 172, put that right in the middle, and then I would just put 3 marks above the mean, 1, 2, 3, 3 marks below the mean, 1, 2, 3, and then I'd label them accordingly. And again, I would just do 172 plus 14, plus 14, plus 14. 172 minus 14, minus 14, minus 14. That's how I would do this type of problem here. Okay, so if I had to sketch my own graph, I think I'd sketch it, and that's going to help me answer the questions better too if I don't have the graph provided for me. Okay, so that's example number 1. That's the first part of what we're talking about today with this normal distribution. Any questions so far on that part, parts A, B, or C there from example 1 and what we did exactly? All right, nothing. Okay, so now what we're going to talk about then is we're going to talk about something called a z-score. And this is the second half of class today. What a z-score is, we can calculate it using this formula. Basically, you take any data point that's given to you, and you're going to subtract the mean and then divide by the standard deviation. Okay? And this is saying, again, standard normal distribution is a normal distribution with a mean of 0 and a standard deviation of 1. That's kind of like our unit circle for trig functions. It's just the standard baseline. This is what we kind of think about for normal distribution. And so the way it works to calculate a z-score is, let's say somebody is on the first problem, their point is 186, their blood pressure. So we want to find out, hey, what's the z-score of that person if their blood pressure was 186? So we'd say 186 minus 172, because that was our mean, divided by 14, because that was the standard deviation. And what's going to happen is we're going to get 186 minus 172 is 14. We're going to get 1. All right. And that's actually what a z-score tells us here is 1. That should sound familiar because that's exactly 1 standard deviation above the mean. So that's what a z-score tells us. So z-score tells us how many standard deviations we are from the mean. So it tells us how many standard deviations we are from the mean. So that z-score of 1 tells us we are 1 standard deviation above the mean, which makes perfect sense. Okay. All right, that's good. 1 standard deviation above the mean, and that totally checks out because our score was 186. We know that was exactly 1 standard deviation above the mean. That's how z-scores work. They're going to give us an exact z location, and we'll talk about, and then we're going to use a table down here to figure out what's the percentage of people that fall in that category. We'll talk about that more in a minute here. But first, I want to look at one more example and say, okay, what happens if we went the other way and we wanted to do 158 instead? Okay. We're not going to get a z-score of 1 this time. I do 158 minus 172 over 14. 158 minus 72, 172 gives me negative 14 over 14. So I end up getting a z-score of negative 1 here. So what does what's that telling us then? What's the difference there? Like, so the z-score of 1 told us that we were 1 standard deviation above the mean. What's the z-score of negative 1 telling us then? So z-score of 1 was telling us we were 1 standard deviation above the mean. What's the z-score of negative 1 telling us?
1 under the mean.
1 standard deviation below the mean, under the mean. Exactly. You've got it. So that's the difference between a negative and a positive z-score. We're either above the mean or below the mean with if it's negative or positive, which is good. And that's what this is showing us down here. So look, if a z of 1 and a z of negative 1, one z-score above the mean, one z-score below the mean. Okay, or one standard deviation above the mean, one standard deviation below the mean. That's the best way to say it. Okay, so the value for a particular x value is called the z-score for the x value, and is the number of standard deviations the x value lies above or below the mean of x bar. Okay, so we just talked about that. If z is a randomly selected value from a standard normal distribution, you can use the table below to find the probability that z is less than or equal to some given value. So this is how it's going to work here. Let me go ahead and draw a normal curve here, and we'll show you how to use this table. Here's my bell curve. And if I gave you, here's your mean. Let's say if we did a z-score here of like 1.3, okay, then what happens is we can say, hey, what's the probability of z is less than or equal to 1.3? What that means is we want to know, hey, what's the probability that if you're doing this and you land here on the table, what's the probability of all of the values below 1.3, including 1.3 as well? All right. So the way the table works is I would look for z of 1, and then I look for 0.3. 1, and then 0.3. And I get a little overlap right there at this 0.9032. All right. That's saying that 90% of my data falls below that z-score. All right. 90% of my data falls below that z-score. Now the problem here is if I went ahead and said, let's find the probability of z is greater than or equal to, let's say, 0.74. All right, so find the probability that z is, oops, I did less than again. Let's fix that. Is greater than z is 0.74. I put my z-score on here. 0.74 is still positive, so it's still going to be on this side of the mean. But this time, going greater than, I would have to do everything up here. So going the opposite direction. Now I would go to my table, and because of the way my table is, I would just round to 0.7. Because my table only goes to the nearest tenth. So round down to 0.7. And I'd find 0, positive 0, and then 0.7. There's a positive 0 and a negative 0, and that's why. And I'm going to get 0.7580. That's how this table works. Okay. But there's one problem with that. What that table tells me, it doesn't tell me the information above that line. It tells me about all the data below that line. So that 0.75 I just found for this z-score of 0.74 or 0.7 is all the stuff down here to the left side. So how would I find the green area to the right instead? That's the question. So that 0.75 is actually this is actually the probability of z being less than 0.7 is 0.7580. But I want the probability of z being greater than 0.7. That's what I asked us to find. How would we do it? What's the what's the total probability of data? Or actually, let's look at it more like a percentage, right? This is 75.8% of the data falls to the left. So what's the total percentage of data in the whole curve? 100, right? There's 100% data in the entire curve, or 1. So we would say 1 minus 0.7580 here. So again, the z-score here, it came out to 0.7580 or 75.8%. So to find the information to the right, I can say 100% minus 75.8, or I could say 1 minus 0.7580. And that's how I'd find the information to the left, which would give me 0.2420 or 24.8% or 24.2%. So the answer would be 0.2420. All right, that's what would happen for that information to if we're looking for something to the right in a greater than instead of a less than scenario. That's what's happening here. Okay. So real important to note here, we have our standard normal table. And again, this is like percentage of data. All right. But it's only a certain percentage of data. One thing we could really call this standard normal distribution table, I've always called it my Beyonce. All right. And that's because this is all the data to the left, to the left. Huh? Right? No?
How is there a negative 0 on the table?
Okay. So there's a negative because we can have negative z-scores as well, right? When negative z-scores falls below the mean and a positive z-score falls to above the mean. So that's why there's a -3, a -2, and a -1, and a -0. It's really negative 0.4, and that's the first example we're going to look at here. It says the table shows z is less than -0.4, so you go -0.4, and you end up with this 0.3446. And you'll find the value of the probability of that. All right. So that's where the negative zero comes in. Okay. But again, this table only talks about all the information to the left of your data point. So if you ever need to find something to the right, you have to do 1 minus or 100% minus that percentage to find the information to the right. That's the key here for these types of problems to be successful on these problems. All right. We're going to look at one more example here. Let's see. So we'll look at example 2 here. I just got to make a little bit of room on my paper. And example 2 says, scientists conducted aerial surveys of a seal sanctuary and recorded the number X of seals they observed during each survey. The number of seals were normally distributed with a mean of 73 seals and a standard deviation of 14.1 seals. Before I do anything else, I'm going to want to just do a quick sketch of my normal distribution before I do anything else. Because I always find this helpful, and we'll just make our mean. 73, and then standard deviation of 14.1. So 73 plus 14.1 is going to be 87.1. 87.1 plus 14.1 is going to be 91, 101.2, and then 115.3. And then we'll do the same thing minus 14.1. So 73 minus 14.1 is 58.9. Minus 14.1 is 44.8. Minus 14.1 is 30.7. All right, and that's going to give us 3 standard deviations above the mean and 3 standard deviations below the mean. And I like doing this first, absolutely first, because Now when I'm asking questions, I can look at this and say, okay, it asks to find the probability that at most 50 seals were observed. So I know 50 is going to fall somewhere between 44.8 and 58.9. And what that does too is I know my z-score at 58 is going to be -1. My z-score at 44.8 is going to be -2. So this tells me right off the bat, my z-score is going to be between -2 and -1. I know that because of where it is on my graph, because I can visually see it now. I can see it on my graph. So that's the first part. I want to find the z-score. So I'm going to take my value 50. That's my observed value. I'm going to subtract the mean, 73, and I'm going to divide by my standard deviation, 14.1. So I end up getting -23 over 14.1. And I get a z-score of -1.6312, and I can just round that to -1.6. That's part A. Okay. Part B now says go ahead and use the table to find the probability that x is less than or equal to 50, or z is less than or equal to -1.6, which means I want to find the probability that when I go out there that I see at most 50 seals. So I'm looking from a helicopter, I'm observing seals, and I'm just counting them, and I've only observed at most 50. What's the probability of that happening? So I go to up here and I go to -1 and then 0.6, and it comes out to this value. So that's the probability of seeing less than or equal to 50 seals is approximately the probability of getting this z-score of -1.6. And that probability comes out to 0.0548, or basically 5.48%. That's what that's telling me. Okay. So that's example B there. And again, because the information falls to the left and I've shaded in the left side, that'll work out perfectly there. Okay. And then the last one, part C, says, let's find the probability that at most 90 seals. So 90 is going to fall up here somewhere. And again, it says at most 90. So that's going to be everything to the left from there. But the first thing I need to do is I would need to calculate that z-score again. So I do 90 minus 73 divided by 14.1. And I can tell right now it's going to be between 1 and 2, that z-score. Between 1 and 2. A lot closer to the 1 it looks like. Hey, settle down. Sorry, my dog is trying to lay down. So I get a z-score of 1.21, and I can just use 1.2 here. And that's what I would use to find on my my sheet up top. So my z-score of 1.2 and the probability of finding at most 90 comes out to 0.8849. So what that's saying again is I'm observing seals from a helicopter and saying I can see any number of seals up to 90 but less than 90. I have an 80% chance of that, 88% chance of that happening. If I see more than 90 seals, it's going to be about an 11.5% chance, right? Because we do the 1 minus. And it makes sense because the mean number of seals is 73. So the fact that I'd see more than the mean, yeah, I mean, more than half of the data set, that makes sense to me. Okay, so that covers our topic for today for this normal distribution and these z-scores. I know it's kind of weird. It's all new stuff for us. But we've got 30 minutes left. We're going to have that graded assignment tomorrow. Remember, tomorrow on the graded assignment, I would recommend strongly that you open it up right at 8:30 in the morning when it unlocks and just check it out and see if you know how to do it, because I have office hours from 10 to 11:30. I'm happy to meet with you during office hours and help you out if you get stuck. But if you don't open it until 5 p.m. just to look at it, then you might not know that you need help. So I'm not saying you need to do it right at 8:30 in the morning. I'm just saying when you open it, just check it out. And then if you need help, you can talk to me during office hours. But you can't do that